Awesome. Thank you so much. Welcome to our webinar. Thanks so much for joining us. You may have seen that we just showed the results of our poll. We have a lot of technicians, tech support, controls engineers who are you guys are the ones that are digging into these files. So I'm really excited that we have you on here today. I have with me Ryan Houston and Daniel Tam, two of my coworkers here at Optigo, and three of us spend a lot of time sitting together poring over Wireshark files in Visual BACnet, trying to figure out what the heck is going on. And so I'm really excited to spend some time troubleshooting with them today and show you exactly what we do on a daily basis here at Optigo. Hi, Ryan and Daniel.
Hi, how are you?
Good, thanks. So we have 5 files that are being shared with us today. We're going to do our best to get to all of them. However, depending on how long each one of them takes, it may or may not take longer. If it does take longer, that's okay. We can always do another one of these sessions. We really want to make sure that you are all super comfortable troubleshooting your files in Visual BACnet. So please, please, please feel like you're sitting at the table with us. If you are totally confused by what you're doing, if you have questions, let us know. We've done this a couple times before, and these guys in particular tend to move pretty quickly. So I will do my best to pull them back and say, wait a minute, why did you do that? But if we all get ahead of you, just let us know, and we'll slow down and explain what we did, how we jumped to that conclusion. For a little bit of background, Daniel is one of our developers here. He's our sort of resident BACnet expert and has really been involved in developing all of the diagnostic checks and a lot of how Visual BACnet works. And Ryan has 15 years of field experience previously with Delta Controls. He's been with us for about a year now, being our strategic solutions provider and helping people use Visual BACnet in the field. So we've got the right team here today. Okay, enough about me talking. Ryan and Daniel, do you guys want to take it away with our first file?
We'll take it away. And we can see the screen and we're good to go?
Yeah, so this first file, I told you guys to take it away, and now I'm going to take it away. This first file is from a hospital. It was submitted to us by Phil. So I'm hoping that Phil is online and can actually tell us a little bit about what was going on. So I'm going to put him on the spot, and Phil, I'm going to unmute you. Phil?
Hello.
Hi. Can you tell us a little bit about what was going on in this hospital and why you thought you needed a file? Let me just fix something.
Well, I've been involved there for a couple of years now and just trying to get the existing network cleaned up. It's about half, well not half, about a third V2 still and 2/3 V3. We just recently implemented a couple of new VLANs to get 2 new buildings onto the network. So I see that the network health has gone down a bit recently, and I'm not too sure why. It was a little higher over the last few months. But yeah, just kind of, you know, I've been poking around with this for a while and trying to do a little sleuthing, and there's a lot of helpful information here. I hope I can find more.
Great. I like to hear that you're being proactive. Okay, so with that, Brian, Daniel, what's the first thing that you're going to do when you take a look at the file?
Well, the number one thing is a health score. I mean, if it's 100%, we're done, we can go home, right? That would be great. But never actually seen a network at 100% yet, unless there's no BACnet data in it. So we know it's a good protocol, but it's tough sometimes. So the first things I look for is I always start at the top, right? How long is this thing? Is it 5 minutes? Is it an hour? Is it 2.5 hours? It really makes a difference. 5-minute capture will give you some detail, but not everything. 2.5 hour capture will give you a lot of information. We typically say an hour is enough. So it's great. There's lots of information here. That's good. The next thing we look for is what's the breakdown of all the traffic, right? There's a lot of non-BACnet traffic on this network, and there's a little bit of a straight BACnet and about 40% of broadcast traffic. 40% is pretty high in the broadcast traffic, so that would be an area of interest right away to go look for. And then we start going down the list. We scroll up a bit and we start looking at the stats. And here, I typically look for how many devices do you have kicking around in this network and how many isolated networks.
So, Phil, can I ask, does 2,200 devices sound accurate? That's about how many devices you have?
Yeah.
Okay. Always a good thing to check, because sometimes it seems totally off, and that's a good flag to start to begin with.
Right, for sure. So the next thing that's really intriguing about this file is when you see in the traffic rate here, you've got a repeating, something's happening repeating, but the interesting part here is it's not in BACnet. As if we isolate BACnet only, this doesn't look too bad. But when you start looking at the non-BACnet traffic, well, something's happening. So normally this traffic would just sit at a normal threshold rate because you have converged networks or there's other type of stuff that happens, not a big deal, but it's the recurring rate that's interesting to us. Now, this may not be a big deal, and it may be just part of the application. I assume because, Phil, you are using Delta controllers, this is probably an IntelliWeb server at this point.
There is an IntelliWeb, yes.
There is a server, okay. So the way you can tell from...
There's two right now.
Okay. Oh, excuse me. The way you can tell is you go into the peak non-BACnet burst traffic, and this is a little tidbit here that we have. It's not BACnet specific, but it does show us some information about what that peak, what those cyclical traffic is looking at. And when it comes up here,
So a lot of data in the file, a lot of non-BACnet data. This is useful because I've had people say, oh, there's only BACnet traffic here. And you go, well, no, that's not true because I can see all of this other traffic. And they go, well, what is it? And so you can go into here and say, oh, it's this type of traffic. And they can go back to IT or their own team and say, okay, it's these types of traffic.
So the interesting part here is that it's the same source, right? Same source, same destination. So odds are, we know it's the Delta controls. It's probably the IntelliWeb server. It's probably going to some BBMD or something on site, and it's doing some proprietary information. So if we take a look further into the Wireshark details, we can see there's standard TCP traffic and there's some SSL traffic. And that's as far as we can look because we don't troubleshoot that side of the network. But our suspicion would be that the server is doing some standard updates, maybe it's doing time syncs, or it's checking on controllers, or it's checking on the network on a periodic time basis. If it was too much, then you could potentially turn it down or slow it down in the application. But for the most part, it's probably fine, and it's not, obviously this part doesn't affect your network, but it does affect how much traffic is coming out of that network pipe.
Okay.
So that's the first start. So if you knew about that and what it's doing, then no big deal. So then we start moving our way down to the next check. Now, you can use this side, this diagnostic check side, because each one of these different checks will be open and ready to view if there's a failed check. But there's a secret little button here in the network health score. And when you click on that, this gives you the same list, but it's reorganized in order of critical functionality to the site. Things like circular networks, not good, fix those first. So we allow you to really focus on what the actual issue is and break down. Right here we can see we have 7 unresponsive routers, right?
So let's tackle that first.
So when we say unresponsive, we don't mean offline because we don't actually know. What we know is we look for we said who is router and nobody answered our question. So that's why these are showing up. So you can click on the line and it'll spit out the answer. So these guys at the bottom, right, for 49999, he only sent out 1 request and he got a response back. Probably not a big deal, might have just missed it in the traffic. But this guy is more interesting, right? 50620, 176 packets. Every time he asks, he doesn't get a response.
Daniel, did you have something to add there?
Right, so it's actually So maybe one device or a couple of other devices that's asking for network 50620. And of all these requests that are sent to find a router to this network, none of them got reply. So it's either the network doesn't exist or the router that's responsible for this network is not responding.
Right. So beware of phantom networks.
Right, so this could be, it's possible it's leftover graphics or leftover programming, asking for something that isn't really there, or it's truly offline. Or there's a lot of cases too that we've seen where the router is also doing programming or serving up some other details, and it simply can't respond to these requests. But when we dig into this a little bit, we can...
I just muted Phil, but I'm muting him again. Phil, do you know if network 50620 is a network that should exist on your system?
I'm actually just online. I'm looking at. I'm going to track it down.
Okay, no worries. Take your time.
Well, according to our system here, it doesn't exist, so it might be hard to find.
So hopefully, we always say when you're troubleshooting a file, have your device list, have your network list available, and then you can cross-reference and say 50620 shouldn't exist. I don't know why everyone's talking to it, and then you can go and troubleshoot devices that are talking to it.
So the interesting part about this, what happens is when you click on it, now we see that there's 5 sources here. 5 controllers are asking for that network. But now you can actually take the data by the Ethernet or MAC address, put it into your system, and see what's going on with that data. Why does it keep asking for that network? So now very quickly we've said, oh, I have an offline or an unresponsive router, and I know the sources that are asking for that network. Let's go look at the source. Right, and then right away, you can go onto your server or whatever you have and start seeing what's going on. Not a lot of information in here at this point, but at least it gives you a good start. So now you can dig into those controllers, look at where all the data transfer is, and see why this network keeps coming up. Unfortunately, the way it is in the world is as we decommission different controllers in different areas of the building, then things get missed, and that's just the nature of the beast. But it does add unnecessary traffic to your network, and the longer that building's around, the more of this you have, and the more just plugged up with stuff it gets.
Yeah, I love those phantom. One of the things that Visual BACnet often finds first on a network is a bunch of phantom devices, networks, things that used to be there but aren't anymore, but someone's still talking to them, unnecessary traffic. So definitely beware of that.
So that would be the first path. Find that unresponsive router, see what's going on. Once those guys come back online, this unresponsive devices, this score should go down. Because if the router's not there, then the devices underneath it are not there, so on and so forth. So I don't even look at the unresponsive devices until the unresponsive routers is clear.
So 6 to 7 routers, and then run another capture, throw it in here, and hopefully you'll have 0 unresponsive routers and 0 unresponsive devices. But then if you have unresponsive devices, then we can start digging into those.
Now, as we keep going down the file, I see some interesting things. There's a couple error responses, but there's 39% in missing acts. That's interesting as well. So once you dive into this, you've got a source here and a destination. Do you have Carpentry on the site, Phil?
I just muted him.
You just muted Phil?
Well, I could hear you back. All right, Phil, you're unmuted.
Yes, there's a
Carpentry on the site?
Yes.
Okay.
And Phil, and you just messaged me, but so everyone knows, you weren't able to find that network in your records, correct?
No, it's not there. That's right.
Okay. So you'll have to go and find those sources that are talking to that network and figure out why they're talking to it and see if it's a real network.
Right.
Simple, right?
Easy.
We've only been here for 10 minutes.
It's pretty interesting.
Yeah, so as you go down, the missing acts is interesting, I always find. This one is obviously one of your copper cubes talking to another one of the controllers. But the interesting part when we look at that is it's asking for a lot of read property multiples, which makes sense. For those of you that don't know, the CopperCube is an archiving solution. It's a hardware appliance that you put on site, and it archives all the information. So it's going to ask for other controllers out there and pull their information back. But what's happening is, if you look into the Wireshark detail and look at the application, it's trying to find the device. Why is it missing actor?
Because that's the request and there's no response to that request.
Right.
So it's asking for a whole bunch of properties.
So it's asking for all this information. So this is the part that probably failed, right? It's asking for the vendor proprietary value, and it doesn't give it, or asking for the name. So there's a bunch of, when you automatically, we see this a lot in analytic services, where, or even third-party gateways, they just automatically ask for the information, but the device you're asking it from doesn't support the property. So it doesn't engage, and it doesn't set or it trips the flag. So there's an awful lot of this happening in the network. Should be easy to fix. You can just specify that that doesn't exist and stop asking for it. But again, it's more traffic, because every time you send the acknowledgement out and you don't get a response, then errors happen, and all of this stuff moves along. But that one's pretty easy to see. We see it a lot in definitely third party. There's a couple problems in the checksum error. This is, checksum's normally either something busy or a hardware fault. This is in the, there's not too much here.
Maybe non-BACnet.
It's a bit in the non-BACnet though. Just some standard ARP requests to TCP. It could be a sign of a switch failing, potentially. Sometimes it could be the sign of a loose connection.
And this is always coming from the same source.
Right, it's all coming from the exact same location. So it might be an idea. It's obviously broadcasting out, but it could be an indication of something happening on the site. You could either go and try and re-terminate the connections, or just keep an eye on it to see if it gets worse. So as we go down, the max network succeeded. This is an interesting check. It's not applicable to everyone. What it means is, if you've got old routing hardware on your site, because there's 133 networks, it has to go through a router somewhere at some point, right? Through a BBMD or some higher level router as your tree topology moves up. Even on a flat network, you have to engage into the network somewhere. So most systems could handle 100 or 150 networks. Some can handle up to 400 or 600 networks. It's always an idea to say, how many am I handling, and can my existing router hardware handle it? If you just go and add another couple of buildings and haven't changed any of that infrastructure, this will trip, and then you could go back into our unresponsive router problem, right? Because you've just put a big load on it that it can't actually take.
Check out global who is. 2,369 global who is in, what did we say, 2 hours?
2.5 hours.
2.5 hours.
So this is a bit interesting, but down here is a score check. They're not as critical, they're more warnings to you, right? Let's start at the top before we get to the global who is. We get all excited. There's a few global private transfers. That's just a non-BACnet way of sending some data up. So every vendor is going to have their own proprietary way. The BACnet broadcast traffic, on average, a good system should be in the 10 to 15 mark. So you're on squeeze high. But we've seen this upwards of 70 or 90 packets per second in broadcast, which is not good.
This one really depends on your network. If you're a small network, you should be in the 5 range. If you're a huge network, this isn't so bad. So this one scales a bit with the size of your site. But if you're noticing problems, there's a good chance that a ton of broadcast traffic is impacting that.
Yeah. So everything else looks pretty good. The who is an interesting number. And what happens here in the who is different vendors' systems go and troll the network for new devices every so often. So those are done in a who is. So segmented who is are also in this check, along with the global who is, right? Just for reference, we are actually looking at separating those. But for now, that's what this means. So I happen to know that the Delta system does go out on a periodic basis to search and make sure the controllers that it knows about are online. And that's what a lot of this is. And you're going to have this twice because you said there's, I believe the Copper Tree system will do that, and you've got 2 IntelliWeb servers. So all of that's being impacted here in the system.
Can you click on that and we can see who's sending those?
Sure can.
Right.
So these are all the sources of who's sending it, which is quite a bit.
So probably not great that you have 18 different devices that are sending global fluids on your network. That first one failed. Do you know what it is? Device 10014?
Do you have any old V3 systems out there? Like the OrcaView? Do you have any OrcaView systems?
Yeah, there's about a dozen OrcaView workstations on the network, and that's probably one of them.
Right. So if you say there's a dozen, we're showing 18 here, so that's 12 away, 2 IntelliWeb servers, a couple copper cubes. It's pretty much your list, right?
Yeah.
So the fact that the top 2 are sending 626 in 2.5 hours is a lot of traffic to be on your system.
Yeah.
So it's always good to look at the time that these are happening. So these are happening every 8.
But these may be segmented. Yeah.
Yeah, it's segmented.
0020120327794. So what we are looking here is within this chunk is probably one whole entire range of fluids, and it's at 1025. So it's
not too bad. It's going to take about 5 to 10 minutes.
So and we see the next one, the next big jump was at 1041. So maybe about 15 minutes. 15 minutes.
And so by going into the frame information and extending the ATDU, you were able to see the device instant range that it was looking for and tell that it wasn't fully global, it was segmented.
Yeah. Cool. Then if you have a non-segmented one, you'll be able to see the time interval more clearly.
Okay. So I mean, the fact that it's segmented at least means it's not fully overloading your network by sending those, but it might be good to see if it can be less than every 15 minutes and expand it every half hour. Does it need to be sending you this often? Hopefully not. And you can save yourself a lot of time.
The next piece is the longest response time.
11 seconds.
That one's pretty bad.
Not ideal?
Not ideal.
Less than ideal, I would call 11 seconds.
The cool thing about longest response time is we actually know where the source and destination is. So right here, device 802, and it's going to device 30,200, and it's taking that long. So this is where we have the information. We can tell you a bit. You have the map. You can tell us what it's going through. It's asking for read data, and it's taking a long time to get it. So when your customers, and they're all out there, complain that the graphics are slow, take a look into this one. Because if you have a graphics refresh of 5 to 10 seconds, plus the 11 seconds to actually get the data, you can be 20 plus seconds before that data refreshes.
Wow.
Yeah.
But this is an easy one because you know the 2 controllers that are in play, and you can look on your map to see what the route is between them and go through start narrowing it down and see what happens. Now, for those of you that don't know, we can actually use this trick. You can always set a read request from between any network or segment from controller to controller. So if your customer is complaining of slow graphics from a specific system, put a read request on it. Let's time it, because we'll time it automatically and you can see what the issue is. You can put it from the server to the end device, you can put it from controller to controller, and it'll show up here, and we can just figure it out. At least you could eliminate it. Very common in lighting. Right, I push the switch and I wait 5 seconds for the lights to turn on. So it's an extra trick you can use to figure out some additional issues. And I think that's the end of this file.
Okay, so in summary, we would recommend that Phil go out and check those unresponsive routers, look at the sources that are trying to talk to that all of those different networks. If the networks exist or should exist, check what that router is doing, see if it's offline or for some reason it's unresponsive. If that network doesn't necessarily exist or you're not sure, check with the sources, see who they're trying to talk to, maybe reconfigure to talk to an actual network. And then maybe look into some of that broadcast traffic and definitely those read requests.
Perfect. Easy one.
Phil, any other questions?
No, that gives me a lot to track down.
So once you track that all down, get another file, and then we'll see where we go from there.
And
sounds good.
That's a great question, Monica, too, is don't be shy about getting these files. Don't be shy about fixing a couple of things and trying it again, and keep moving progressively through it. There's each of these accounts have lots of credits in them. I mean, it's going to be hard to run out of them, so you'll be fine. Okay, let's hop into.
All right, so our next file, I'm going to mute you. Thank you so much, Phil.
You're welcome.
I'm going to mute you, and I believe we have Alan online. I'm going to put on the spot here. Oh, do I still have Alan online? Yes.
Yes.
His boss sent in the file, so hopefully this isn't a big surprise for you, Alan. Hi, Alan. Well, you're unmuted, so hopefully you say something at some point, Alan. This is a file from a corporate campus that was submitted to us, and so I don't have a ton of context, but I know there's been a lot of issues on site, and I'm not really sure what issues. Actually, we're going to take a second maybe to see while Alan can get audio. We're also going to get a better camera for you guys over here so that you can see all of Daniel's face and not just half of it. I promise the right side of Daniel's face is just as good looking as the left.
Thanks, Courtney.
All right. So this is a corporate campus file, big site, a bit bigger than that hospital was. I think this is probably just a section of it, and I know they've had a lot of issues, so nothing specific that I was told to look for, but let's see what we can find. There we go. So 19%, not ideal. We are aiming high here in network health. This is in the top right corner. I can see that it's a half-hour file, so not as long as maybe we'd like, but still a decent file. Take it away.
Take it away. Do you want this one, Daniel?
You go for this one, right? I'll take the next one.
All right. So here we are, the half-hour file. Again, there's 500,000 packets in this file, so that's pretty intense. That's quite up there. Not a lot of non-BACnet, which is good to see. There's 72% almost in BACnet and very little broadcast. So those are all good signs. Not too much broadcast traffic. That's key to a file. Out of the 27 or 30 checks that we have, 27 regular checks, 3 MSTP. Only 6 have failed and 3 in warning. Looking pretty good. There's almost 3,400 devices. That sounds about right.
Wow. Alan's
We don't have
online,
audio, so we can't talk to him.
I'm going to have a microphone.
Yeah. Well, he's called in, but I'll try not to.
So here out of the BACnet rate, here's an interesting thing is, on average, we're only running, a couple hundred packets per second, which isn't, it's a little high, but it's not too bad. But there's some massive spikes happening here. They've got a few spikes over 4 kilo packets per second. And that's happening every 10 minutes about.
Whoa.
Exactly at 10 minutes. So this is something we're definitely going to investigate and see what's happening there, because that's what we like to call a more of a broadcast storm, and see what is going on. So something on a periodic basis is just blasting this network. So that's where this graph really comes into play. So we can go in and figure it out. As we didn't do in the last file, there's a bunch of extra tools here. We don't always need them. We just use them depending on what information we found. Phil's file was fairly simple to go through in the changes. I suspect this one is not going to treat us as nice. But that's okay. That's why we're here. So, awful lot of red in this one, but that's okay. So right at the top, we see our friend duplicate networks popping up. Now, if anyone's seen this from previous webinars, we know that a duplicate network is multiple routers that are claiming route to the same network. So these three networks on the left are the ones in question, and they all have multiple routers going to it.
That top one has 3 going to it. Great.
So you're not out of luck. It tells you what devices they are, which is these 3. So at least right away. So normally this is a logical problem. Somebody's messed up a network address is what's happened here. Network number. So easy enough. We go, here's the network we have. Here are the 3 sources, and we can go in and fix it. We almost don't need to go into the Wireshark detail because that's the only information we need. So you can go right away, fix that up, and you'll be ready to go. Now, unfortunately, what happens is when you have 3 sources of this, these 3 guys, they're each going to have a few devices hanging underneath each one of these. And all of those devices probably won't show up online because he's only going to see a selection of the actual devices from the network that he's on and the network that he's supposed to be on. Those devices don't have a network router, so they're not going to be online. So the cool part is, once you fix these, then this unresponsive devices should come down by a long way because there's a lot that aren't actually being routed to the network and are out there flailing away. Make sense?
I think so.
So once you get that taken care of, that's a pretty simple one to go after. The next one is the unresponsive routers. And again, same as the last capture, we'll know which ones they are, we know what networks they're trying to go to, and try and fix them up.
So if I was to take a guess, some of those ones that have 1 packet maybe are not real networks, but I'm guessing 24001 is a real router or network that should have a router because there's 13,000 packets being sent to in half an hour.
It should have.
So probably that guy's offline.
Now, this is where it gets interesting. A lot of this is normally black and white, true or false, right? It's online or it's offline, and nothing in between. But when you get into situations like this one, where you're having the ratios a little bit mixed, right? So this was 99%, which isn't too bad. Let me open this up a little bit more. So now we get into some 98%, some 96%. So it's sort of online, but it's not really black and white. This guy, for example, this guy sent a ton of packets, only missed 1. So that is something to check. Maybe it's wiring, maybe it's something else. It could be affected to probably that duplicate network problem. So if you change that, get another capture, see what this is going on. That would be our point of advice.
And you'll notice that on the diagnostic list, it said that there were 9 unresponsive routers, but in this list there's 21. That's why. We show you any that didn't respond, but we only count the 100% unresponsive ones in the unresponsive routers for the diagnostic check.
Right. So when I look at a file like this, my first instinct is duplicate network, go fix it, and then run another capture. I wouldn't continue to work on this because once you fix the duplicate network, you're going to see a lot of other things change. And right away, this file will be out of date. So that would be my overall suggestion at the time. Anything else in here?
Can we check out some of those, the broadcast traffic and the long response time?
So broadcast traffic.
While you're doing that, Ryan submitted a question about how we use Visual BACnet to check the Mftp network. So Ryan, our next file, I believe, is an Mftp file, and we'll tell you a little bit about how to get that file.
Right.
I'm not ignoring it.
So when we look at the BACnet broadcast traffic, we can see who all the sources are. But there's another little tool that we're about to show you where most of the traffic sits. So this is here where a lot of traffic hangs out. But if we go to the BACnet browser, BACnet Browser shows us traffic and time coordinated together and gives us a great list, a really great view of what's happening. Yeah, this is quite a big file. It's a pretty big network.
Crunching them all and dividing them into those little categories. One of the cool things about the BACnet browser is the ability to sort by vendor, which is not what we're going to use right now, but it's cool.
So you can see here that there's about 5 guys that are handling most of the traffic. And this looks like it's an automated logic site based on who they are. Cool part about that is you can simply click into it, start drilling down to the filters. Okay, so we have the one source that we clicked on, and it's sending an even amount of traffic to all of these guys. There's actually a lot of information here. Even if we show, let's go to 50 entries. Right, so it's pretty evenly distributing a lot of information. But the question we have is, what are you sending? So again, keep drilling down. And here's the interesting part. Remember that traffic we had that was in the 10 after 12 mark, 600 packets? Here it is. We've actually stumbled across it and started to see what the actual source was. And the actual source is the atomic right.
Wow.
So we don't exactly know what that is, but there's a lot of writing being done, and there's a lot of information we can't pick out.
Between source 24.118 and source 37.99.
I would guess there's proprietary nature to this. Would you say?
And right, can we go back to the list, source list, and instead of drilling down in destination, can we go right into the service choice?
Mm-hmm.
That would give us a list of the top service choice that particular source is sending, regardless of the destination.
Once it comes up.
If you guys have any questions as we're working our way through this, please.
Do you want to go to this one?
Yep, first one, and then this one first. Okay. So with this, we can see which service choice was the one that's most used.
So we can still see this. So every 12 o'clock, 12:10, 12:20, the same thing, and it's doing all of this information.
Ton of read range.
Most of it's read range. So on a periodic basis, every 10 minutes, it's doing a massive go out and get read range. Our suggestion in this site would be to try and slow that down. I wouldn't say slow it down, but try and spread it out if that's even possible in the application.
Just click on that read range. So it's device 249991 that is doing a lot of those read ranges. So go to that, guys. See if you can have less frequent read ranges.
So that would be our suggestion on this one. Is there anything else that we wanted to look at? The time response, correct?
Yeah, I'd probably link. Probably by fixing those things, you fix those read ranges, you'll get a lot of traffic off the network, so that will help.
So it's true, 24.11, which is the originator, it looks like it's here as well, going to this device. It was the one doing all those requests and all that information. So there's probably something, there could be a router below that's choking, that can't really deliver the information as fast. So it's easy to find. It's probably, this guy's probably the router, or 2 routers, and that would be where your choke point is. So either figure it out, or I know ALC is coming out with a brand new router, so upgrade it, and it should solve part of your problems.
Yeah. Or find somewhere else to capture on the network. So find a way to capture on that router, by that router, to drill down and figure out where that problem is.
Yeah, that's another piece. If you're stuck for information, it could just be where we're capturing. We can only see what you give us.
Yeah. So as a rule of thumb, this is going to segue very well into Ryan's question in our next file. As a rule of thumb, typically people will capture at the server to start off with, get a bit of a view into what's going on in the overall network. And then when you figure out the areas that have issues, you can go and try and capture in those specific areas. And so if it's an MSTP network, you're going to have to go and actually wire into an MSTP network and capture the tokens on that MSTP network. We have a couple options for this. We do have an article on our support forum. So we have a support forum, zendesk.oxford.net, and you can go in there and there's articles on every single diagnostic check and different ways to capture, including how to capture MSTP traffic. And if you wire in, you can capture there, and then these, you'll see that, you can see on Ryan's screen here that the token disruptions diagnostic, as well as two others for MSTP, are grayed out. If you put in an MFTP file, those will automatically be green, or hopefully green, maybe red. The other option is we did just launch, very exciting, Mftp Capture tool. You can wire it in and have it automatically capture and upload to Visual BACnet on a regular basis or as often as you want. So try and enable you to get those files from the exact location you want. So slowly but surely you'll be able to capture everywhere.
So what's next on our list?
Next is the shopping mall. Jake just asked if we have any files that use the capture tool. To be honest, I'm not sure how people captured their files.
Do we have any capture using our capture tool?
I'm not sure. I didn't ask people how they capture it, so.
Not to the moment. The only ones that have been out are a few beta sites, and we haven't really seen the results of those. But yeah.
Although I think a few people that submitted these may be beta customers, so probably not, but there is a chance that one of these is. I just don't know it.
Okay, so this is Daniel, if you will.
All right. So 58%, I would say it's not that bad, but it's an MSTP site from, you can see from the graph here. It's, instead of non-BACnet, it shows MSTP. And what's very interesting here is that between, say, 350 and 410, there's a spike of MSTP traffic. And we can see that the BACnet traffic is close to zero.
Oh, it's inverse. Wow.
Mm-hmm. And then after that, everything seems to be back to normal. So, like, what we hypothesize first is that majority of the problem may lie in this particular chunk. So, some token might get lost, or the server just went down and recovered itself after that point. So what we did was to make sure that the problem is actually between this period of time, we actually trim the capture and analyze what's after to make sure that it's all good. So I'm going to bring up the capture that we trimmed. You can see that the health is significantly better, but there are still token disruptions. So if we
what we're saying is we haven't fixed the actual problem yet or know what it is, but we've isolated the better traffic so that we can make sure that anything after the spike is solid and hoping to narrow down what that spike is.
So before we split, we see a very long token round trip time and also a lot of token disruptions. What we are expecting to see in the good one is that it'll be a lot more stable. So not as many token disruptions, but what we see here is there are still token disruptions, and the average token round trip time is still very long.
That's insane. What is that? Almost.
That is almost 19 seconds.
Whoa.
So there's something wrong with the token passing. So click into it, and we can actually see how the token is being passed. So what I'm going to do here is I'm going to sort by the destination, and then click on the source. So this will show us what sources are passing, which sources are passing the token to which destination. So from here we can see that source 0 is always passing to 1, 0 to 2, 0 to 3, 0 to 4. So that is not how an MSTP chain usually works. And if we go on further, it seems like source 0 is always passing the token to each of the MSTP masters in the chain. And when we hit 1, we can see that 1 is only passing the token to 0, and 2 is passing the token to also to 0, 3 is to 0.
So this isn't daisy chain at all.
Yeah. It seems like the token passing mechanism here is
Non-existent.
it's not standard. And that would explain the token disruptions. So for token disruptions, we are looking at reply to poll for masters. So in a stable network where there are no new devices, reply to poll for masters should never happen. So say I believe it's at every 50 token passing, the master with the highest number will send out a poll for master to figure out new devices.
To see if he's the highest one.
Mm-hmm. But in this case, we can see that, so this is a reply. So the sender was 0 send out a poll for master, 1 send out a poll for master, 2 send out a poll for master. So basically, almost every device here send out a poll for master. That's because in the token passing, the devices are configured to pass the token to 0, which is a number lower than its own device number. And that's why it thinks that it's the highest, basically the highest device, the last device in the chain. But in actual fact, there are other devices which are numbered higher than them. And all these devices responded with a reply to poll for master. And interesting enough, these replies are not actually being registered. So it's sort of getting ignored because we never see that the token get passed from 1 to 2, but still 1 to 0.
So it
even
says,
after the reply.
who's the master? It says, I'm the master, and it says, I don't care, I'm going to pass back to 0 anyway.
Mm-hmm.
So where do we go from here?
So
your device configuration is completely...
So either that, so there could be a couple of things in this file. Do you think they're in a star topology? It's hard to say. It could be that. There could be an extra capacitance on the wire. At this point, if you came back to us and said this is truly wired in a daisy chain fashion on a straight 2-wire network.
So I asked him.
Is he online?
I don't know. Can we hear you?
Hi. Could I write in chat? I think it will be better. Okay.
So is this is a daisy chain Mftp chain?
I'm sorry. I'm sorry, I didn't hear. Could you repeat, please?
Oh, is this network daisy chain? It's 0 to talk to 1, 1 to talk to 2, 2 to talk to 3, like an Mftp chain?
Well, let me try to tell you what is happening. I think you did not introduce what has really happened. The major problem with that network that we found is because that network at these. Well, let me write. I think it will be better. Just a minute.
Sure, I can, okay. So it's a BACnet network of a shopping mall. It has 59 Schneider BACnet PLCs and 1 automation server. The main problem is that the network suddenly goes down for no reason and then comes back by itself. It seems like when the capture goes down, there's a lot of malformed packets spamming the network with no necessary reason. And so he captured on the Mrcc network. So we've actually cut out of this file the section of going down because we want to just troubleshoot the good part and make sure it's okay, because maybe that section is so troublesome that it's causing it to go crazy. So if we can make that better, then we'll deal with the really bad stuff.
It's interesting. I looked at a file the other day that looked very similar in the round token, the round trip token times. The result of that was the integrator had to go to site and using an oscilloscope to look at the shape of the MSTP packets. As we know, they should be a nice, sharp 0 and 1. What this was doing, it was actually a nice shark's tooth coming down. So the 0 and 1 threshold was a little bit questionable. It was creating a lot of misinformation in the packets and causing a lot of this type of data. So our suggestion at this point, and unfortunate as it is, to get a little bit more detail, we're going to need to take a look at what the packets will look like from an oscilloscope point of view. Because if you've truly wired it up in a 2-wire daisy chain nature, then the only next logical step is to start isolating to the hardware and to the potential shape of those waves, just to make sure that they're not giving us something weird. There could be too much capacitance on the wire when you connect too much in there. There could be a lot of issues, but it's definitely pointing us to a hardware problem over potential software.
So why are we thinking that this isn't a wiring problem?
Why are we thinking it is a wiring problem?
Well, we're thinking it's a hardware problem rather than a wiring problem, correct? So a lot of the time we see really messed up MSTP networks that are wiring. This one we think is the actual devices.
The easiest way to that is normally when we see, sorry Daniel, I'll steal it a little bit. Normally when we see the average round trip token times, we don't see anything in this range, right? We're talking 21 seconds to go around. Normally that's 400 or 500 milliseconds, super fast. And because it's way outside of the range is why it kind of triggers us to that. Okay. It's pretty wild.
And so he's actually tried to do that isolation, and he's isolated. This is a panel of 7 PLCs that he thinks are the problematic ones.
Okay. So
potentially go to those devices, and either there's something crazy configuration, or the devices are just need to be replaced.
Yeah, potential. But that's definitely the path you're on. But and at minimum, one of the things that this tool could have helped you with is, and I can't stress this enough as you're building 2-wire networks, get our capture tool, put it on before you put the first device on, right? Because then you would start with your main router, go to your first device, and if you saw this problem right away, you could stop and try and correct it at that time. As you add on 20, 30 devices, it gets harder and harder. So that's in a time-saving perspective on site, that would be our suggested method. Not always possible on site, but if you can, it would be the best way.
So another Ryan just jumped in with the comment or a question saying, shouldn't these devices be sending to the next device and not back to 0? So yes, just to clarify, you shouldn't go back to 0 every time. It should go 1 to 2 to 3 to 4 to 5. That's the crux of what's wrong here. It's going back to 0 every time. And likely, if you solve that problem, a lot of the other stuff would get solved. But how to figure out exactly why it's doing that would require looking at the physical devices.
Right. So this requires some on-site work.
Sorry, gotta roll that track.
Thanks for the file, Diego.
Yeah. So we have about 5 more minutes. We want to take a look at that university one quickly. See if we can. I'm going to challenge you to see what you can do in 5 minutes.
5 minutes.
You want to do 5 minutes?
5 minutes.
5 minutes. University. Let's go.
I'm not even going to get context from Steve. We're going.
Okay.
What do we have? 76%. Do we
98% non-BACnet. So very little BACnet traffic.
Very little BACnet traffic in here, that's correct. But based on the little amount of BACnet traffic that we have, there are quite a few unresponsive devices.
But no unresponsive routers.
That means the routers are up, the routers are happy.
But the devices are not.
But we do have some global WHOIS router, that's interesting. So right away, before I started tackling this, I always like to check in the bottom and see what's going on here. This is all pretty good. BACnet traffic, broadcast rate's low, but this is interesting, the global WHOIS router. What this is telling me, since your routers are online, routers are not overloaded. What this tells me is all of these sources are looking, they're scanning the entire network and saying, okay, everyone give me their path. Tell me who you're connected to, and let me know what all the router paths is so I can let the rest of the network know. So if you want to go from here to here, I can tell you. So all of these, how many entries? We have 50 entries here that are doing the same thing.
And if we drill down into this one, you can see that it's actually sending out the request every 2 minutes consistently.
So this would lead us to configuration. There's something in the configuration that sends out this global whois router request every 2 minutes from all these sources. It's quite a bit of traffic. That's definitely unnecessary. Once you get the information from a router that comes online, that should be it. It should never change.
And we see some other sources are sending the same request out every half hour. So which is more acceptable than every 2 minutes?
Yeah, that's we see a lot of that. Sometimes some devices are just configured to ask that. They reset their router table. If you can reduce it, it's good because then you don't have unnecessary traffic. But hopefully your network's not changing every half hour that you need it to be asking that often. But it may or may not be reconfigurable.
It depends on the device. Sometimes when you put a device online, it goes, I am router to network and I'm here to dominate the world. And it lets you know and updates everyone's table. Sometimes you have to ask. So that's where the issue is here. So you would have to go in. Obviously, we don't know anything about the application here, so you would have to go in and modify this.
And then those duplicate devices.
No duplicates here?
Yeah, devices. Sorry, unresponsive devices.
Right.
Sorry. I knew it was devices. So these guys, again, same as the networks, they may or may not exist. So hopefully Steve has a table, a list of all the devices on his network. Often he can even glance and go, whoa, number 4, or, oh yeah, no, that's a different numbering scheme, so it makes sense that it's completely different.
Wow, odds are that some of these, this number here, the 4194, I believe that's the highest range in BACnet. So that can't be a possible number. Number 4, very unlikely it's a real device, probably some sort of testing code.
And you also see like consecutive device ID, like 1677050515253.
Yeah, these ranges.
So he's saying he does have some different device numberings, and he knows that he has his device tables, but he has 2 different vendors. So lots of fun keeping track of the different devices for different vendors.
Well, that's why we're here, is to manage our vendors. So the interesting part about it too is you can actually figure out where it's coming from, right? So when we look at this guy, somebody's looking for it, device is online. But when you click on him, the guy who's looking for it is this guy. So that's easy. At least we narrow it down. It's like, okay, at first I know there's a device online. Okay, now I say, oh, it's coming from this guy. So I can go straight to the controller and figure out the data exchange on why it's looking for that guy.
So if it's offline, it should exist. Go to that device, fix it, figure out why it's offline. If that device shouldn't exist, find the source who's talking to it, reconfigure. And that's the same for anything that's offline or unresponsive.
So what's actually happening is this guy's saying, I am looking for this device, right, specifically. So who is? If somebody says, I want to send data over there, the guy goes, okay, how do I get there? Here's the route. Where is this guy? So that's what's happening here.
You have 30 seconds on your 1-minute challenge.
30 seconds? How are we doing?
5-minute challenge.
So sometimes for NPD you'll see a source address and source network instead of the IP, use that source network and source address instead, because the IP may just be the IP of the router.
It's possible. But in this case, it's actually the IP of the router.
IP of the device.
Okay.
Okay,
that's the summary on that file.
We do have a couple more files that we weren't able to get to, so we will try and do this again. And those of you who if there are more people that have files that you'd like us to do on a live webinar like this, or there's more interest, let us know. We will do more of this if you guys want us to do it, but we don't want to just sit in the room by ourselves and do it. So let us know if you like this and if you want us to do more. Otherwise, best of luck troubleshooting your files. Go and find those phantom devices And thank you so much, Ryan and Daniel, for being on the webinar today.
Happy hunting. Hope it helped you.
Good luck. Thanks. Bye.